Jai Hind, all of you. Welcome to the chemistry class again. So today we'll discuss about that molecular mass and that how to calculate molecular mass. So first of all, in last day we have talked about that atomic mass. Now one question is coming in that respect, that why we are taking that standard taken as the standard for the calculation of relative atomic mass. So from the questions you can get that why we are taking the carbon 12. So as you know that carbon 12 number of proton and number of neutron both are present as a number 6. If I talk about the carbon atom, that carbon has a proton number and neutron number both 6, and also its relative atomic mass, it is generally present as a 99%. This isotope is generally present as a almost 99% as a isotope. So we are taking it as a reference. Now next question is there, what will be the mass of one atom of carbon 12 in gram? So we know that 1 AMU equals to that 1.66 into 10 to the minus 30. That when I talk about that, what will be the mass of one atom of carbon 12 gram? So 12 gram, 1 mole of carbon has mass 12 gram. We know about this one. And in 1 mole, how many atoms is there? We know very well. That is the Avogadro number of atoms. Avogadro number of atoms. 6.22 into 10 to the power 23. Now suppose I am taking that one atom of carbon. So what you have to do? You have to divide Avogadro number to 12. 6.022 into 10 to the power 23. So after calculating, what you will get? You will get the value 1.99 into 10 to the power minus 27 gram. So this will be the answer. Okay. Now we are moving to the next part. Okay, 10 to the power minus 30, 23, not 20, 23. Okay. Now coming back to the point, molecular mass. If I talk about that molecular mass, so how can we calculate the molecular mass? Molecular mass is a simple thing. When we are talking about a molecule, obviously some atoms are mixed there in a fixed ratio and it is form a molecule. So when I talk about the molecular mass is a nothing but sum of atomic masses of the element present in the molecule. So how can we calculate a molecular mass? Suppose I am taking an example of H2O. Suppose I am taking an example of H2O. So we know that atomic mass of hydrogen. So here is the number of molecule of hydrogen. That hydrogen atom has a 2 number and oxygen has a 1 number is there. And we know that if I talk about the atomic mass, then atomic mass for hydrogen is a 1 and oxygen is a 16. So if I calculating these 2 into 1 plus 16, so what we are getting? We are getting that 18 micron, you can say 18 micron. Now if I talk about that, okay, if I am writing this unit as a 18 gram, so it represents that gram molar mass. Gram per mole also we are writing, it is called the gram molar mass. So we have to remember this one. Okay, sometimes we are also writing that 18 gram per mole. Now what does it means formula mass? So when few substances are there, those who are generally present as a discrete molecule, they are not like that water, they are not like that carbon dioxide, they are forming from the cation and anion. Like if I am giving an example, that NaCl generally present as a Na plus and Cl minus, and by this way they are forming a discrete type molecule, and that time for this type of molecules we are not calculating the molecular masses. That time we are using a new term that is called formula mass. So if I ask talking about that what is the formula mass of NaCl, so we can easily calculate that Na has a mass 23 micron and chlorine has a mass 35.5 micron. 35.5 micron. So what is the mass of NaCl? So we can calculate easily if just summing up for NaCl, and you will get 58.5 gram per mole, you can say. So by this way you can easily solve any molecular masses. Okay, that is a very important, that you have to know the sum of atomic masses, because again I am telling that when we are practicing continuously, through the practice obviously it is in your mind that what will be the atomic mass of oxygen, what will be the atomic mass of hydrogen, sodium, potassium. So don't expect that every time the atomic mass will be given. So you have to practice this and you have to earn this one. Now if I talk about that, few question is there, so one by one we'll discuss that. Calculate the molar mass of ethane. This molecule is known as the ethane. So we know, here I am just writing that if I talk about the carbon, it has atomic mass 12. If I talk about the hydrogen, atomic mass is 1. If I talk about the oxygen, the atomic mass of 16. If I talk about the sulfur, it has a atomic mass 32. And if I talk about the phosphorus, it has a mass 31. So the 5 elements generally present in these 4 molecules. If I talk about the first one, that C2H6, so what will be the molar mass or molecular mass? Obviously when I talk about the molecular mass, so C2, that means 24 plus 6, that is a 30 gram per mole, you can say 30 gram per mole, you can say as answer, 30 gram per mole. So next one, if I talk about that, the C12H22O11, you know very well that what is the formula. This is the sucrose. C12H22O11 is the formula of sucrose. H22O11. All the masses you know. If you just calculating like this, that 12 into 12 plus 22 into 1. If I asking about the oxygen, that 11 multiply with the 16. So after calculating all the part, what you will get? You will get that 342 gram per mole. So I hope you understand that how to do the calculation for the molecular masses. If I going to the sulfuric acid and the phosphoric acid, let's see that what will be the molecular mass for the sulfuric acid, H2SO4. If I talk about the H2SO4, what you have to do? You just add all the masses, you will get the exact that molecular mass of the sulfuric acid. For sulfur it is the 32 and the 4 oxygen it would be the 64. So what value we are getting? That we are getting 98 gram per mole. So similarly if I talk about that phosphoric acid H3PO4, so we will get, I hope you can understand this one, that 3 plus 31 and this is a 64 is there, because 4 oxygen is there. So what is coming? It is again coming this 98 gram per mole. So remember that for phosphoric acid and for sulfuric acid, the value, the molecular mass value will be same. So by this way we can easily calculate the molecular mass. I hope you can understand this portion at least. Now one question is there which you have to know, that if two elements can combine to form more than one compound, the masses of one element that combine with a fixed mass of the other element are in a whole number ratio. Obviously in last class we have read about the different law of with the 5 basic law of chemical combination we have read. Already I have uploaded that video, you can also check that in my playlist. So what is this law is telling? This law is telling about that when any element is there, two element is there which combine to form more than one compound, obviously from that idea you can say the answer, yes, this statement is a true and this follow the which law? Law of multiple proportion law. So very important law, and who is given this law? This law is given by the John Dalton on the year of 1803. So law of multiple proportion law. So the name of the law is very important here, and as the law already is given here, so you have to remember. Now the question is there, give one example related to this law. So the question is also very easy. Suppose water and hydrogen peroxide. Last day also I give this example. Hydrogen peroxide I am taking as example. So what you are getting that in every case hydrogen present as a 2 gram. Hydrogen present as a 2 gram. But in the first case in the water oxygen present as a 16 gram, but in the second game oxygen present as a 32 gram. And if you just check this, that oxygen in the case of water and oxygen in the case of hydrogen peroxide, both are present in the 1:2 in simple ratio. So that is called the law of multiple proportion. I hope you understand this theory of law of multiple proportion and why it is important. So after this one, we are moving to our new concept, that is the mole concept. I cannot say this one is a new concept. Already in class 10 you have read about the mole concept. So when I talk about the mole, you know that SI unit of a amount of substance is known as a mole. So if I talk at that what is the mole, so you have to tell that 1 mole is the amount of a substance that contain Avogadro number of elements. Again I am repeating my word, that when I talk about that 1 mole of a substance, you have to tell that, okay, you have to think that the amount of substance that contain that Avogadro number element, that is the 6.022 into 10 to the power 23 number of element. Also one definition is given, you can give this definition in another way, that 1 mole is the amount of a substance that contain as many particles or entities as there are atom in exactly 12 gram of C12H2. So both the way of telling the answer is define the mole is correct. But the important point you have to remember that whenever I talk about the mole, the number is fixed, that the element number is 6.022 into 10 to the power 23 number. Okay. Now next one in the picture you can see that number of moles and the volume of a gas in a liter at STP is interrelated. Again you can see that when we talk about the volume in at STP means the standard temperature and pressure. At that time the temperature has been taken that 270 25 degrees centigrade. STP means standard temperature and pressure. Now what is telling that 1 mole of a substance or 1 mole of a gas, 1 mole gas always contain 22.4 liter substance, 22.4 liter of gas. It is a very important part that you have to remember, that whenever I talk about the 1 mole of gas, that time it means that it contains that 22.4 liters. So in the here you can see that it has been written that under STP condition 1 mole of any gas occupies a constant volume. The volume is 22.4 liter. So the value is a very important, 22.4 liter, the value you have to remember. So I hope understand the mole concept. So one more example I am just giving you. Suppose I have the 3 component. One is the 1 mole of, before moving to this part I am just asking one question, I am just telling one part, that if I have that 1 mole of carbon dioxide, 1 mole of carbon dioxide, if I have that 1 mole of lithium, 1 mole of helium molecules, you can say helium gas, and 1 mole of that hydrogen gas. So what you can see here, that in every case the number of entities will be fixed. In every case the number of entities will fix. Why I am calling it a entities? Because for the case of the carbon dioxide it will be the molecules. For the helium it is also called the molecules, because helium molecules, and for hydrogen we are talking about the molecules. Okay, and helium also you can call it an atom as well. Okay, because helium is a monoatomic molecule. Now they are coming to these questions, that if the question is that 1.1 liter of a gas at STP weigh 1.97 gram, what is the molecular mass? So read the question again, that 1 liter of a gas at STP So we know that at STP, that 1 liter of gas, if the 1 liter of gas contain that 1.97 gram, so if I think at the temperature and pressure is fixed, that the STP, so on the 22.4 liter gas it will be contain 1.96 97 multiplied 22.4 liter, 22.4 liter. So what will be the answer will come? Think about that, you will get your answer. It will come, so I will suppose that 44 point something. It will come as a 44 point something. So I think that 7, I think it will come 44.7 gram. Okay. So by this way we can easily solve the problem. So this is the type of problem which is really coming in the examination as well. So whenever you are getting time, so read these things and practice these questions. So one more questions we can touch, that if the question is coming that calculate the number of moles in the molecular masses. So I am just giving you the formula that you have to remember that number of moles, how can you count? The number of moles always counted by this formula, weight by molar mass, weight by molar mass. So remember this formula, that whenever we have to count that number of moles, we have to use that weight by molar mass formula. So here the iron molecule is there, iron molecule. So what is the molar mass of iron molecule? The weight has been given here 7.85 gram and the molar mass of iron is a 56. Okay, 56 gram. So what the value will come? The value will become as a 0.14, 0.149 I think, but we are taking the up to 2 decimals, 0.14, sorry, 0.14 mole. It is a not gram. It is a not gram, it is a mole. It is a mole. Because the question is asking that how many moles are there. Okay, so 0.14 moles. So I hope you have understand about the molecular masses and the mole concept. So again we'll come with the new videos. Till then, take care, goodbye, Jai Hind.